Okay everyone, so this is problem 2.10 out of Griffith's quantum mechanics textbook, and it's regarding the harmonic oscillator. So we're going to work this problem out, but before I do, if you wouldn't mind please liking this video and subscribing. I'm trying to build my channel a little bit before I start graduate school, so I would greatly appreciate any support I could get. Okay, so part A wants us to construct psi 2 sub x. And the way that we're going to do this is starting with the fact that our ground state is m omega divided by pi h bar to the power 1/4, so 4, e to the power minus m. Stupid text mode keeps popping up. That's just a reoccurring theme at this point. Over 2h bar x squared. And our ladder operator that acts on our ground state will bring us psi 1 of x. So our ladder operator, we're going to operate to get psi 1, and then what we're going to do is have the ladder operator act again on psi 1 of x to get psi 2 of x. And obviously we already have psi naught, but in the process we'll get psi 1, and then in part B we can get some sort of sketch of these wave functions. So that's kind of our strategy. Okay, so let's start by having our ladder operator operate on psi naught. So I'm just going to go ahead and plug in what our ladder operator does, our raising operator in this case. That's our ladder operator. This is our ground state. Okay, so this term here is essentially a constant, so that I can pull out okay. And then I'm going to distribute the E across. So we have our constant terms times m omega over pi h bar to the 1/4 times minus h bar, the derivative with respect to x of our exponential part here, plus m omega x e to the minus m omega divided by 2h bar x squared. Okay, so this derivative isn't too bad. We're going to have just minus h bar times, I'm going to ignore this these constants, but they'll come back, times minus 2 m omega over 2h bar x e to the minus m omega over 2h bar x squared. That's just a pretty standard derivative, and plus m omega x e to the minus m omega divided by 2h bar x squared. This is all times our constants out front. So obviously this one simplifies a little bit. The negatives go, the h bar goes, and the 2 goes. And we're left with m omega x e to the minus m omega, all that good stuff. So this is just, these are the same terms now. So we can simplify that to be 1 over 2 h bar m omega square root times m omega divided by pi h bar to the 1/4 times 2 m omega x e to the minus m omega x squared divided by 2h bar. So this is our psi 1. And we're going to need to graph that, so this is worth just kind of looking at. And the way that we find psi 2 is we just have our raising operator act on psi 1 of x. So we're going to follow essentially the same process here. Just will be a little messier. So now when we pull this, we have this term, but then we have another term, that exact same term coming from when we apply the ladder operator. So that'll be just 1 over 2h bar m omega. And of course we're going to have our m omega over pi h bar to the 1/4. That's not going anywhere. Minus h bar d by dx plus m omega x. Yeah. And then times, what do we have left? 2m omega x e to the minus m. I think my pen is hitting the mic, so sorry about that. Okay. And once again, well, let's simplify this. The 2 cancels, the m cancels, the omega cancels, so that's really nice. And we're left with just 1 over h bar m omega over pi h bar to the 1/4. And now we're going to have to distribute this. We have minus h bar d by dx of x e to the minus m omega over 2 h bar x squared plus m omega x e to the minus m omega x squared over 2h bar. Okay. Alright, so I'll just keep writing these constants out this time. Alright, so let's see derivative of the first. This is a product rule. So we have e to the minus m omega over 2 h bar x squared plus x times derivative of the second part. So we've kind of already done that. It'll be minus m omega over h bar e to the minus m x. Let me not forget that x because that's important to have. E to the minus m omega divided by 2h bar x squared. Okay. Actually, we don't want to close that off yet because we still have this term. So that's fine. And then plus m omega x e to the minus m omega divided by 2h bar x squared. Okay. So let's see. We can factor out a couple terms here. So both terms here have this e term that can be factored out. So let's go ahead and do that. That'll be left with 1 minus x m omega over h bar. That's everything. And then plus, we can also factor this term out as well, can't we? Well, let's just write it out like this, it doesn't matter. M omega x e to the minus m omega over 2 h bar x squared. So what we could do is factor out this e term as well. And I think we can do most of this without doing anything too crazy. So let's just drop this parentheses. Let's go ahead and get rid of this term. But there's also this h bar out front, so I would say we'd want to divide this by h bar. Okay, just a little algebra mistake here that I forgot when I tried to put it all in parentheses, that there was this negative out front. So if we wanted it to be positive, then that needs to be negative. And now we're not getting 0, which is good because we didn't want that. So let's see, we can pull this out so the h bars cancel, and the negative 1 we can distribute. This is now minus 2 m omega x over h bar, which of course will turn positive when we distribute that negative. So side 2 of x is m omega over pi h bar to the 1/4 times e to the minus m omega over 2 h bar x squared. Then after we distribute the negative, another little error that I missed while I was doing this is that x should be squared, of course, so that is my bad. Okay, so that should be squared minus 1, and that is psi 2 of x. So to graph this is pretty easy. You can just kind of plug this into any sort of graphing calculator, and you'll get something that looks like this. For psi naught, for psi 1. These aren't perfect, but they just kind of get you the idea. For psi 2. And the important thing to know is that psi naught is even, psi 1 is odd, and psi 2 is also even. So then we know that an even function times an odd function on a symmetric interval is 0. So in other words, we know that say psi naught star psi 1, we integrate this, that'll be 0, and so will if we switch and do psi 1 psi 2, because they're odd and even. So the only ones we need to check are really the two even functions. So the only part left is to show that psi 2 star psi naught dx is in fact equal to 0. And we already found these values, so all we have to do is plug those in. So again, psi 2 was found here, and then psi naught is just that wave function. So what are we going to have? Well, we're going to have m omega over 2 pi h bar square root, because it was to the 1/4, but there's two of them now. We're multiplying them. And then we integrate over all space, So we just plug this in, h bar x squared minus 1 e to the minus m omega over h bar x squared. So essentially, because psi naught just has this e naught term, you're basically multiplying this times this one. So instead of it being all that minus m omega over 2 h bar x squared, the 2 goes away. It's just like a half times a half, or a half plus a half, or times a half. With exponents we add them. So this is now the integral we want to do. And you could do it a couple ways. You could distribute this to make two integrals and work it out that way, or you could plug this into an integral calculator at this point and you'll see that you get 0, which means that the eigenstates are in fact orthogonal. So hopefully that helps. If it did, please like and subscribe, and thank you.